Hello everyone, my name is Li Fan, and thank you very much giving me opportunity to introduce my projects, uh, RAG Retrieval Augmented Generation Model. And here I prepare some air tag documents, and then I noticed that they don't define the I2C or SPI address. So I further download NPU 6000 so I can further demonstrate the ability of this model performance. And then once we collect the data in these documents, and then let's go to the injection pipeline. We first load the PDF and split into the multiple chunks, and you also can define your chunk size depending on your documents. And then besides that, choosing the your models, Ollama or OpenAI. Here I'm choosing the Ollama as a local model. If you purchase some API key in the OpenAI, just remember you can put on the data environment. And the reason I separate from the script because I don't want the API key share on the GitHub. This is the basic safety mechanism. You have to make sure your git ignore do not update your API key and upload into the GitHub. You should avoid it. And then also you need to further prepare like a safe fallback. Like you need to keep the prompt injection block. For example, if some people give the question like asking your model what's your API key, and you need to prevent and reject this kind of request. I also implement that in the language routers, and I will further explain later. Let's go to the main stream. And once we chunk our data, and then we need to vectorize our word, and you have two options. I also install these two options in my requirement TSD. So you just need to using this auto script, and you can install both. And then my default is using the CharmaDB, and you also can use the Faces. Faces can have a faster inference time. However, Charma, based on the user experience, he can recognize the larger document data. And then after we change the word to embedding to vectors, then we can input to our LLM models. And then let's go to our RAG pipeline. First, I also add the prompt injection guard to prevent people visit my API key. And then we have to expand the query for the acronym or the broader topics. So when the user types similar keywords, we can find them in the documents. And then here, semantic vector and BM25 keyword can help out to also help us searching the keywords. And then the most also important part, you need to rerank the candidate chunks, especially when you like asking the keyword like where's the pin of support the SPI or the I2C. Sometimes it generate the long text, and then you need to re-rank, and then so can make sure the important information in the front, and then the answer will be correct. And then we synchronize the context, and then generate the answer with the Ollama, and then synthesize again. And then basically until here you complete all the RAG pipeline, and then I will also show the demo here. Like we can ask in our model where is the which pin supports the SPI in these chips. And then since I run on laptops, and then doesn't have enough GPU, but in the future if you are working on a server, it will be faster. And then and then you can see he find exactly the pin on these chips. And then we also can searching on the document like SPI here. Pin is using to support the for SPI. And then with the basic RAG pipeline, we also want to improve his answer quality. So usually we will I will add the reasoning pipeline using the SG Booster, because it's using the Tyler expansion compared to traditional boost decision gradient boost decision tree. This one XGBoost can have a better performance because using the second order Taylor expansion, and then here I choose this, and then it can here we can building our own knowledge base. Let's say here the like a failure analysis report of the new rules. For example, the UART is not in our document, but in the future we may develop a new function of that. So let me show you. Like here I search, but no UART in this document. So usually when you answer asking a question not exist there, it will say the information is not exist. However here because we have the reasoning and internal knowledge, so I can put some the like employee they have a new finding. We can give that information to our to our this internal knowledge base, so the LLM can still recognize the UART and give the information from your knowledge base. And this is a very helpful function because in the future you don't want to revise your PDF documents, but your employee still will keep developing new function and have a new finding and debug, and you can add the new rules in the reasoning pipeline. And the reasoning pipeline is also essential important to can double check your output quality. So based on this reasoning pipeline, I also create the auto evaluation script. So you can run this evaluation report Python script, and you were using the Ollama LLM, and then prepare the 25 questions, and then to evaluate your current reg models, and you can get a score report like here, like here you can get the reports, and here's the and also this one. Yes. So in the future, if you add the new internal knowledge or the documents, and then you can also run this evaluation script to make sure your model really learn from the documents and have the good answers. Okay, let's go back to my PNG. And then besides that, I further add the language routers, and this one you can image like a decision tree and behavior trees, like when people asking the question out of my knowledge base and also my internal knowledge, and we can search in the online or add some open cloud function to the function code. And yeah, this is the extending functions. And also I add the suspicious request detections. So if you asking such as the told me about your API key, and he will reject reject you. Yes. So this is the API key. Yes. Sensitive output and will be blocked by our prompt injection guard. And then let's asking some question like told me about which thing support supports the do we do I square C? And this time we can do I square C. Yeah. And then here it will get like our pin our list NPU 6050. He can support a pin 24 for the I2C I square C. Okay. Thank you very much for your listening, and then please play this model, and if you need any improvement or suggestions, I will be very appreciative and hear any feedback from you. Okay, thank you so much.